All right, welcome everybody. Open Source Antibiotics Series 2, meeting on Friday, September the 18th. Let me share my screen, which is this one, I think. Is that all right? Hopefully everyone can see that.
Yep.
All right, fantastic. That's it. Okay, so I mean, there's a bunch of things here from last time which are the same. So mechanism of action work is ongoing. I've had a few emails back and forth from Lee Graves and Caro Wells about doing that work at UNC, and they've got some MRSA and they're doing the experiments. So it all looks like it's going ahead, which is great. I think we should just check in on them in a week or so and see how it's going. Monash hasn't come back to us with data, I don't think yet, so we're still awaiting that. Screening for potency by Paul Stapleton. He said he's happy to carry on screening compounds, which is good. Short delay because term's beginning and lots of teaching's happening, but he's happy to carry on, which is good. And it's on me to action this thing about tox screening, which I think will be possible soon, but I think the relevant student has just started. On biofunctionalization and similarity landscape, I'm still waiting on clearance to talk about those. So again, nothing for me to do there, but I'll chase them, make sure we can talk about what's going on with those two companies. We should try and highlight the new data we've got because I think it's exciting that we're generating compounds and data, and to highlight the new compounds that are coming in, which we'll talk about in a second, from Ben Perry at DNDi. So I think we should try and organize a little tiny micro video to promote the fact that things are being contributed. Still nothing from Bill Zurcher about the original COAD report. So I'll try one more time, and then if not, I'll just directly go to COAD. And those are sort of the quick things at the beginning. I need to change the order of this a little bit to highlight the big things. But the big things I think are going to be a little bit about chemistry and a little bit about compound donations. So maybe we can just talk about the compounds incoming. So as a result of the conversation we had last week, which Ben was part of, he identified these compounds as being DNDi compounds that were related to ours. So just as a refresher, I don't know how I can easily make this, okay, it's easier, let's see. So the issue we had last time was that these fused imidazole pyridine compounds we thought were inactive, but that's because, of course, as we realized last time, we'd kind of got the wrong substituent on the rings. So wait, let me just bring up the actual thing so we can see the structures just to make sure everyone's up to speed. So these are the original data we had, and this was the resynthesis compound that we found was inactive, and we realized that actually this part was then a problem. And most of the compounds we had data for had this substituent on there, including this imidazole pyridine compound, which is the ones we're just talking about here. So including that core had the wrong substituent on. So we need to re-examine whether this compound may be active. And Ben was looking at a bunch of compounds which had that unit in it, and it's found all these compounds that we can have evaluated against MRSA. So he's emailed the 3 owners of these compounds, and certainly one of them, the biggest supplier, TCGS Life Sciences, have said that they are shipping, which is really good. So hang on a second. Yeah, 3 units, TCG Life Sciences, and Imperial and Northeastern have other compounds that are available. So he's emailed all of those, and hopefully shipping will be incoming from all of them, which is amazing. So Dana, you're acting as recipient, for better or worse, of those compounds. And then Paul's happy to screen them. So there's a lot there. Of course, I mean, all data is good data. I mean, all of these share this feature, of course. And so we hope that, that core does not compromise the activity, but they've all got the same 2 pyridine, not all of them. They've all got a 2 coordinating motif here. Well, actually, most of them do, but some of them don't. But it's a nice scatter of compounds around that basic core for free, which is really good, and in the open. So that's absolutely fantastic. Hopefully that will, boost our SAR a bit.
Good.
Yeah, very nice. So they'll come in and probably get data on those in a couple of weeks, I would guess, based on Paul Stapleton's availability. Okay, and then, so we'll just chase those shipments, I guess. The other thing was just to catch up on the chemistry. I mean, if you guys wanted to, have you got a slide you could share?
Yeah.
Cool.
Okay, so this is my sort of stuff. I've been working on trying to get the unsubstituted imidazole core. Well, so I guess first of all, I did make this DMK 136 compound with just a phenyl ring because I thought that might turn out to be, you know, a useful kind of baseline compound that should be made. So I just went ahead and made that. And then I got the starting materials in for these triazole idea that I had. So I put this on the Gashira on last night. So there's still starting material this morning, but there's a couple other spots on the TLC. So I kind of just kicked the heat up on this reaction. I'm going to check it tomorrow. And then, yeah, so the unsubstituted or the methyl substituted imidazole core, the coupling reactions are a bit problematic. So this is just sort of a summary of some things that I've presented already, but essentially the stuff that I've tried. So putting the methyl on is fine. You get a mixture of the 4 and the 5 bromo because it isomerizes, but they're separable. Then I was trying with the trityl group to do the couplings, and then the idea would be to take that off so you just have the NH as the final compound. Those have been a bit problematic, so the latest thing that I've done is put a tazole on it instead to see if maybe the electronics or the fact that it's a little bit less bulky would maybe help with the coupling reactions a little bit. So that's where I'm at.
What was I going to say? Yeah, I mean, this is the kind of neat late stage introduction of that to pyridyl.
Yeah.
I guess we don't have a microwave in the lab, right? But the TRO has one.
Yeah, I've used it before, so I can contact Sally Oxenford and see if I can use it again. Yeah, that's also a good. Yeah.
If heating gives some sort of hint that things are changing, then you could just blitz it in the microwave.
Mm-hmm.
See what you get.
Cool. Yeah, and then the next slide is just sort of a summary of the cores that we're actively pursuing, and then just 2 of these other ideas that I had of cores that we could maybe think about making. But these I'm gonna kind of hold off on until I can get the chemistry working on the unsubstituted imidazole. So I think it's going to be similar chemistry there.
Okay. Yeah, I mean, I also forgot to mention, that looks really good. I also forgot to mention so I guess the chemical methodology from Laurie, we got
yes.
There, right?
Yeah, I have. So she sent me their literature references and then the procedure that they ended up using to make those compounds.
And it's so the same core that is being shipped from the NDI, right?
Yes.
Okay. I'm just going to add a note to the thing about that.
Yeah, I mean, I guess I can put those in the repository, and would that be useful then?
Yeah, if she's okay with that, right?
Okay, I'll just double check.
I mean, so what that means is, hang on a second. I guess that, you know, if the screen of these donated compounds looks promising, then we have the methodology to explore it quite easily. Yeah.
I remember when they were making those, and the isocyanates, they smell so bad.
Right.
So that's gonna, I think, well, we'll need to handle them in a hood and use the toxic rhodopsin stuff, but it is a one pot, so that's kind of nice.
Yeah. Okay. It's a test of the lab facilities we have that we can handle. Okay. Awesome. Great.
And then, yeah, so for my stuff, I've just done a scale up of making this benzothiophene boronate so that we can couple it to, I guess, you know, all the cores that we'll be making. I also thought it might be good to scale up that oxidation again, because I guess there was probably like 10% of that N oxide product. So there's like possibly something else in there that I could fish out. But yeah, a larger scale would help with that. And then, so for all these ones on the bottom, the reagents have come in. So I got the 3 and 4 pyridine to make those cores. So those I can do next week. I also got this amino pyridine to make that core, which we were talking about just through the same method we've been using. And then this one I found, so when I was looking for, I guess, heterocyclic replacements for the 2-pyridine, I think I've got them on the next slide, but I've just gotten the cheaper ones first. So there's this pyrazine one, and there's literature procedures to just brominate that, which is pretty straightforward, and then you can make the core with that. And then this was also pretty cheap, so I got that, and we can make that core as well, just to check. And then from last week, I think Mandrake suggested we get some of these because they were pretty cheap. So I got this sulfone, methyl sulfone, boronic acid, and this bromide, which I can just borylate. And hopefully that is a bit easier than like this kind of method. And then, so the other thing that I've ordered is this isomer, which I guess put through the same bromination and core. And yeah, I guess this one won't have that 2-position nitrogen for like possible chelation. And then also I found a paper, I came across this from a group at Vanderbilt, I think, where they make the core from this reagent, so the brominated core, and then they did a Suzuki to give like these kind of compounds. And then, so I mean, that would be really good for diversifying. You know, you could just do Suzuki's on both positions essentially. And so, yeah, Dana suggested if we iodinate at the other position, then you could probably do like successive Suzuki's at each position to get, you know, lots of compounds a lot quicker. And I also found this core, it's a bit more expensive, but it's also available for a similar thing. So I don't know, we could pursue that. I could buy some of this stuff if you think it's worth it.
Well, it depends, right? I mean, if the subsequent couplings are efficient, then 1 gram of that stuff, $78 or whatever it is worth it, because then you can get a bunch of compounds very quickly.
Yeah.
It depends where the low yielding step is, I guess.
Yeah. So I think this step is pretty good. From the paper, the Suzuki's give variable yields from like, I guess, 10-ish to like 50, 60, which I guess is similar to our Suzuki's anyway.
Interesting.
And then, yeah, so these ones are things that I was looking for to substitute. Like a lot of them are pretty expensive. So I've just gotten the ones that are cheap, which I showed before. So these ones here, I guess were from Ben's suggestions. I mean, they're not, I can zoom in a little bit. They're not terribly accessible. through our method, but I don't know if this method works, then it's probably a bit easier to get the bromide of those.
You mean
And what's that?
You mean in Suzuki them all?
Yeah, yeah. And then I think I saw from what you posted as well about looking at alkoxy substituents.
Yeah, I think Ben had some.
Yeah, we have this in the lab, which,
Seriously.
yeah, we could make some of. I don't know. We could just wait until we get.
Yeah, put it on the list. It's a nice one to have
Yeah.
as a point of diversity, just because you've got a mildly chelating oxygen there.
Yeah.
Yeah, so, and if that one's active too, then we've gotten rid of the 2-pyridyl also. Yeah, I think go for it.
Yeah, I mean, nothing wrong with that at all. Yeah.
So how much is shipping from Combi to
I think they increased it since the last time. Yeah. I think they have it on the website.
Sounds like you're getting delivery quickly though.
Yeah. Like I ordered all those things like 2 days ago, and they all came in.
Looks good to me. So, I mean, this has a lot of searching you've done. So yeah, do post this obviously on the site, because that's really useful. I have a record of all these things that we can get hold of pretty easily.
Yeah, so combi block shipping is $72.
I couldn't possibly comment.
Yeah.
But the Vanderbilt thing you found, that's a nice starting material.
Yeah.
On in bulk.
Yeah.
That seems like an easy route. See how we go, I guess. I mean, do you have a priority here of a sequence of events with loads of possibilities?
Yeah, there's a lot of things. I think the first thing would be to make these ones, the 3 and 4 pyridine.
Yeah.
With the benzothiophene, just to check those.
Yeah.
And then probably make some of this core after that. And then, yeah, we'll see from there.
I mean, I guess the compound that I posted in my comment about the compound that we want with that core, but with the benzothiophene. So the one that's in the top of your slide there, but with the fused aromatic ring.
This one?
No, the one above. Yeah, sorry. Yeah, the combination of those two.
Yeah.
That's the sort of high priority one, isn't it?
Yeah.
Right. Fine. Because we don't have that in Ben's set.
Yeah.
Okay. Yeah, and then the 3 and 4 isomers of the pyridine and the sulfoxide sulfone compounds. I guess those are all important as short-term targets.
Yeah.
Sounds good to me. Cool. All right, great. Chris, are we missing any tricks?
I don't think so. I mean, I think what you need to do is obviously get these compounds made and get them tested. I mean, I think a few more examples with that benzothiophene at the top left to be very useful to have.
Yeah. Okay. Awesome. Great. I think that's everything. There's a bunch of other little minor things on the GitHub issue, but we don't need to talk about them. So that's all good. Great. Nice plan, guys. Really good.
Okay.
See you all next time.
See you then.
Bye.
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 Bye.